Hello class, and this is Mr. Eggleston, and this is Algebra 1, and this is the lesson 8.4, Transformations of Exponential Functions. Basically, we're going to graph equations of the form y equals a times b to the x. Notice there's a number now other than the base in front. Or we're going to look at y equals b to the x, then we're going to add k to it. All right, so we're going to see what these things will do to the graph and identify the domain, the range, y-intercept, and the asymptote. We're also going to describe how the parameters of y equals a times b to the x plus k affects the y-intercept of the graph, the steepness of the graph, and the horizontal asymptote. All right? All right, so here we go. Yesterday, we looked at f of x equals 2 to the x. Today, we'll look at g of x equals 3 times 2 to the x. What is the same about the equation of the two functions? What is different? So notice, f of x is 2 to the x, and g of x is 3 times 2 to the x. Well, what's the same? Both, that's a little too fat. Okay, both f of x and g of x have the same base, which is 2. They are both 2 to the x. G of x has a 3 in front of 2 to the x, and that's the difference. So now it says, let's go to Desmos.com. I've downloaded it onto my iPad, and you should have too. So we got g of x equals 3 times 2 to the x, and they want us to see what the sketch looks like. Okay, so there is g of x, and I'm going to graph it for you. Boom, or I have it graph it for you. So there's the graph. Notice the y-intercept is 0, 3, and that as we move out here to the left, the graph is going down to 0, so it has the same horizontal asymptote. And as we move to the right, the graph blows up. The main thing is that it looks like the y-intercept shifted up 3 units because it was at 1 and now it's at 3. Okay? So let's graph this on to here. So instead of 0, 1, it's 0, 3. 1, 2, 3. And then when we go over 1, it'll be 3 times 2 to the first is 6. 8, 7, 6. When x is 2, that'll be 3 squared, which is 9, times 3 is 27. So here's 20, 5, 6, 7. All right. Oh. All right, so now, and then when we're at -1, it will be 3 times 1/2, which is 1.5. Oh, it's right there. And then it's just going to keep getting lower and closer. So we have this. All right. And notice the horizontal, or not the horizontal, but the y-intercept. What is the y-intercept? 0, 3. What is the equation of the horizontal asymptote? Y equals 0. Okay? So the y-intercept of the original function of f of x was 0, 1. Now with the 3 in front, we're multiplying the output of f of x by 3. So 1 times 3 gives us 3. Or excuse me, yeah, 1 times 3. So the original was 1, and then we multiplied that because of the 3 in front right here. We get the output to be 3. So we stretched the graph up by a factor of 3. So that is a vertical stretch. So here we go. That's a 3 times 2 to the x. The 3 is said to be a vertical stretch. By a factor of 3. Okay, that means whatever 2 to the x is, like when x is 1, that's 2 to the first is 2, but then we have to take that 2 and multiply it by the 3. That's in front by this number, so it'll be 2 times 3 is 6. And when x is 2, you'd have 2 squared is 4, and then you triple it by multiplying by 3, and that'd be 12. And so we're stretching the graph. Okay. The horizontal asymptote, it's still y equals 0 because as we approach, as we go out here to down to negative infinity, this graph keeps getting closer and closer to 0. Okay. It's just that it grows 3 times faster because we're multiplying each output by 3. Okay, so now they ask us to use Desmos to graph h of x equals 2 to the x with a plus 7 on the outside. So we turn that one off and we turn that one on. Oh, if it will go on, come on. There we go. And notice that the graph, instead of being at the ordered pair 0, 1, is now at 0, 8. Okay, remember f of x was just 2 to the power of x. There's the original, all right? There's 0, 1 of the original 2 to the x. This is 0, 8. It's 7 more because we added 7 at the back end, okay? So describe the difference, sketch the graph. So it is 0, 0, 8. That's the wrong one. When x is 1, that'll be 2 plus 7 is 9. When x is 2, 2 squared is 4 plus 7 is 11. Right? 4 plus 7 is 11. So 8, 9, 10. That's 8. Oh, that's 8, 9, 10, 11. When x is 3, 2 to the third is 8, plus 7 is 15. And then when x is 4, 2 to the fourth is 16, plus 7 is 23. And it looks like this graph is going to do this. The y-intercept shifted up 7. There's the horizontal asymptote, which was down here at 0, y equals 0 down here on the x-axis, got shifted up 7. Okay. How does this graph compare to the original graph from yesterday? H of x is translated as the technical math term up 7 units. All right, notice at 0, instead of being at 0, 1, which would have been down here, right there, it's at 0, 8, because we went 1 plus 7. Also, the horizontal asymptote of the original was y equals 0. Now it is y equals 7. This is the horizontal asymptote. It shifted up 7 units. So what is the y-intercept? The y-intercept is 0, 8. What is the equation of the horizontal asymptote? Well, the HA is simply y equals 7. So the y-intercept, so the rules are this with the plus 7. It's a vertical, this is a vertical shift up 7 units. Because of that, the y-intercept, which was original, was 0, 1, is now for h of x at y equals 1 plus 7, which is 8. I'm sorry, which was the original 0. Okay, for h of x, the horizontal asymptote for f of x is y equals 0. So for h of x, the horizontal asymptote is 0 plus 7, which is 7. I was mixing up the horizontal asymptote and the y-intercept. All right? So everything shifts up. So without graphing, predict whether you think the graph of y equals 2 to the x minus 4 will look like. After everyone in your group shared their prediction, check your prediction with Desmos. So now they want you to imagine what this would look like. Well, it will be this, the graph will be the same as 2 to the power of x, only all points are shifted down because we're subtracting 4 units. So how can you find, so that means the horizontal asymptote for this one would be at y equals -4 instead of y equals 0. Okay? And the y-intercept would be at, instead of 0, 1, it'll be at 0, -3. It's 1 minus 4. Okay? So we just subtracted 4 from all the asymptote equation and the y-intercept. Explain how you can find the y-intercept of any exponential without graphing. Always, and this goes for any graph, set x equals 0. Oh, come on. X equals 0 and evaluate. That will give you the y-intercept. Explain how you can find the horizontal asymptote of any exponential function without graphing. Look for any number being added or subtracted from the exponential, from like b to the x. All right? And so there you go. So it's the shift. Lastly, here are the transformation and exponential functions. Quick notes. Parent functions can be transformed by stretching and shifting. A stretch is when you multiply the exponential by a number, right here. The number is a. It's a vertical stretch by a factor of a. Has the same asymptote, because the asymptote is when x gets really big negatively or positively, but just the b to the x goes down to 0. So it's the same horizontal asymptote. The y-intercept, though, you put 0 in for x, because that's how you always evaluate the y-intercept. X is 0. That's a times 1, which is a. So the y-intercept is a. And the range is y is greater than 0. Now, when we transform it by adding the number on the outside as plus k, that's a shift. K units either up or down, depending upon if it's k is positive, it'll be up. K is negative, it'll be down. All right? Y equals k is the equation of the asymptote. So whatever that number is, plus 5 or minus 2, that's the horizontal asymptote. The y-intercept, you just let x equal 0, and it's 1 plus k. And the range is y is greater than k now. And there you go.